Okay, let's continue to talk about the functional programming. There are several functional programming skills that we must master when we are reading or learning how to write the Python codes. The functions are the first class objects, and it can be used as any data type. For example, the arguments to the function, return values to functions assigned to variables, parts of tuples, lists, etc. etc. For example, you can define the square function as to return the square of the arguments. You input 5, it's going to return 5 times 5, which is 25. And then you can define another applier function, which has 2 arguments, and the first argument is a function, okay, which is very interesting if you really think about it. First, I define this function. So if I enter 6, I'm going to get 36. If I have 10, I will have 100. Okay. Then I can define another function called applier, which is a function. I don't use Q, I just use function. Okay. And the input arguments. There are 2 arguments in this applier function, and the first argument is a function itself. Remember that we don't have the parentheses after this function name, and we just return the function of x. And what is applier square? And let's say 7. It's going to be 49, because applier square 7 is basically returning you the square 7, and square 7 is returning you the 7 times 7, which is 49. Okay. Another one is lambda notation. Lambda is, so I used to read a article talking about what is the most magic thing that you can find in the Python programming compared to the others. Not just one, but multiple people say like lambda notation is one of the most magical things in Python. That is, you don't have to define a function with a name. For example, if you just want to use a function for just once or twice, you don't have to define a name, because when you define too many function names, you forget what these function names are when you write too many codes. So you can just define the function as anonymous, a function without a name. That is a lambda function. Okay. For example, you can define the function as +1 x and return x plus 1. You can do this, and guess what? If you do +1 6, you're gonna have 7. But you see that writing so much is not very convenient. So there is an easier way to write this as lambda. Lambda function is followed with, okay, you don't have the parentheses here. You just follow with the argument, and you follow what you're gonna write in the return function here. This is a lambda function. Okay. And how to use it? Think about this function. You just assume that this is +1, and just use 6. It's going to give you a 7. It's going to give you 6, and use. You're going to get 938. Okay. And you can also define it as f equals lambda function, and f can be used as a function. When you don't want to have this f, you can rename it as 5. Then f is 5. Then f. So f doesn't have to be a function, okay? Then it will give you nothing, because you say like f is an integer, so it's like 5, 4. It doesn't really mean anything. So you can just define f as a lambda function. When you don't have to use this function anymore, you define f as anything else. This is lambda. You also apply. Remember that the applier function that we just defined. You want to define the applier function and use the argument of 6. But in the first, you can use, you just directly put the lambda function here. It's just a function. And it's going to give you a 7. And or you can just use f here because you have already defined the lambda function. You assign the lambda function to f. So f is now a function. Okay. Note that only one expression in the lambda body, its value is always returned. Always returned. And it has, we're not getting into the depth, but Python supports functional programming idioms like map, filter, closures, continuations, etc. A lot of them. If you just look at the documentation online, you can check the detailed description of them. But I'm gonna talk about the map and reduce. Here, look at another lambda function. So here, lambda has what's the input here? What's the argument here? The argument is a tuple. Okay, it's a tuple of x and y, and it's going to return 2 times x plus y, and this is a function. Okay, when you define this function as f, and you take the value 3 and 4, it's going to be 3 and 4 are separately, respectively, assigned to x and y, and you calculate 2 times 3 plus 4, which is 10. Okay, you're going to get 10. Yeah, so this is just what I did. So this is a function. You use parentheses to enclose them. Then you have the argument followed by this function. Now we are talking about the map. You can map a function to every element of a collection data type. For example, map, you define add1x as, if you define add1x, x plus 1, this is add1. Add1 is like our plus 1. This is the same thing that I did. And also you can define it as f equals lambda. Well, actually, f is such a function. F6. I just defined it. See, it's plus 1. So you can map this function, for example, add1, to each element of this, each item of this data collection type, and you will have what's going on? Let me think about it. Maybe yeah, Python 3. This should be a Python 2 code that I use. So in Python 3, it's a map object. Okay, it returns a map object, and you have to convert it into a list to use the list function. Okay, that's a bit different from the previous version. And if I change it to f, I'm gonna get the same thing because f is defined as lambda x plus 1. Okay. So map function is to map this function to each element of a data collection. Let me doesn't really have a good example to make. Yeah, no. So I return the x to the power of 3, and I'm doing this. Then I'm gonna return a list of that every element is previous list's elements power of 3. Okay. Here is an example saying like you have to put a function as the first argument of the map, not an operator. Here you will have a arrow throughout, and you cannot execute this this statement because plus is operator, not a function. It's an operator, not a function. If you really want to use a map, the plus you wanna add each the two lists of you wanna add calculate the sum of the corresponding elements in the two lists. You should first define a function called add xy, return the x plus y. Then you map this function to both lists. So each item of this list will be used to do this. Okay. Okay. I think it still will return a map object rather than the list. Okay. Yep. Okay. So this is 11, 22, 33, and 44. Or you can import an operator module. Operator is a package that we're gonna talk about in the lecture 2. This is everything that I talked about in the lecture 1 slide. Okay, for Python we only have 2 slides. The first lecture 1, this is lecture 1, the very basic things. And the second lecture notes, we will talk about the packages. The operator is a package module, and from this module we import everything. When you use star, it means that we import every function. And within this module, within this operator package, we have a function called add, so you can directly use it. For example, there is another function called subtract. So you subtract each element of the first list from the corresponding item in the second list. Then you will have this. Okay. Filter. Okay, there is another function called filter, and reduce. Reduce is saying like you wanna calculate for all the item in a data collection data type. For example, a list. You want to use a function to apply to each one of the items, but not unlike map. You're not returning a list of the same length. You are returning a single number. It's 1 plus 2 plus 3 plus 4. Okay, let me first import the module. Now I have the add. Try add. Yeah. Okay. Okay. It doesn't support like 3 items, so you can only have like 2. And let me do reduce add. And 1, 2, 3. It's gonna be 6, I guess. It's gonna be calculated as 1 plus 2 plus 3. No, it's not. Why is that? Let me think about it. Okay. I searched a bit and find that in Python 3 we have to import the reduce first. Unlike map, we have to. It's been put into the FilterReduce package. So we have to use this first. And the reduce function has 3 has 3 arguments. The first must be a function. Okay, it's a function like add, and the second is a sequence, and the third is an initial. The initial is default to be 0. So if you have add and 1, 2, 3 with initialize with this is default as 0. Okay, you may not enter it, and it's going to be calculated as 1 plus 2 plus 3. So the last argument initializer is defaulted as 0. The default value is 0, so 0 plus 1 plus 2 plus 3. That's the algorithm. So you will have 6. If you put, say, 1 here, it's going to calculate a 1 plus this 1 plus 1 plus 2 plus 3. You're going to get 7. Okay, so this is an algorithm. Okay. Again, let's think about the filter. Filter is a function that will check whether each element of the data collection data type is true or satisfies a criteria or not. For example, this filter function it checks whether each item in this list is an odd number or even number. If it's odd number, then it will return it will be kept. If it's even number, it will be removed. Let's first define the odd number. If x divided by 2, and we have 1 left, then there's an odd number, which is the definition of the odd number. If x can be divided by 2, then we return false. Okay. And after we defined it, we try odd 1, which is true, and odd 6, which is false. This is just to confirm that our definition of the odd function is correct. Now we are applying this filter function here, and filter function can be filter. Okay, so it has arguments. The function and the arguments, the data collection object, and the list is a data collection of different items, and we want to check if each item is odd or not, and it will return us a list of only the odd numbers. For example, here we can also define a lambda function. Like, for example, x true if x smaller than 3. This is a lambda function, and we do 2. And okay, this is right. Why is this right? Oh, this is to check whether x. So this is an expression, and this is a Boolean expression, and it's gonna return true if this expression is satisfied, and if it's for example, it's 4, it's gonna return you a false, and here it's gonna return you a true. So you can apply the lambda function as a criteria to filter the item in this data collection. I was stupid to write this, but we actually can modify this a little bit. For example, we define smaller 3 3 as a function, and if x is smaller than 3, we return true, else we return false. And smaller 3, 6, 5, it must be false. So we can modify this one a little bit as smaller 3. Okay, it's gonna return us the same 1, 2. From the two example, we can also see how convenient the lambda function is. Okay, rather than writing such a long function that will never be used again, using a lambda is pretty convenient. Also, you can, if you think like the filter function is not very beautiful, you can use list comprehension. For example, list comprehension can give you, for example, the x for x in and it's gonna give you the original list. So you can just use a list comprehension, or you can add multiple criteria. Okay, so it's gonna filter out 1 and 2 and more than 3, and the x is greater than 4. Okay, this is called list comprehension. This is an alternative way of doing this filtering. Okay, if you're interested, you can take a look at the Python documentation. Here you have the just Google map filter and reduce. It's going to have multiple different examples. Okay. If you want to take a look at the list comprehension, there is also list comprehension here. Take a look at the web link, and you can check them and study by yourself. Okay, this is just a screenshot of the documentation, and lecture 1 is over. After this lecture, we will keep talking about. Well, let's make a brief summary. So we learned the conditional statements. Okay, the if else if loops, the for loops, while loops. Okay, and the functions. We also learned exception handling. And in the next slides, we will in the lecture 2, we will talk about the packages, especially the data processing packages that this course is focusing on. Okay, I'll see you next video.